So today's lesson is going to be on the Dalton's laws of partial pressure. And what this says is the total pressure of a system equals the sum of each individual gas within the system. So if I had a system that was made up of nitrogen and oxygen, the total pressure of this system would be equal to the sum of the pressure of the nitrogens and the pressure of the oxygens. Okay, so let's look at some examples. And now this is your Dalton laws of partial pressure, which I put onto the website for you. I have a 250 ml sample of oxygen. It is collected over water at 25 degrees Celsius, 760 torr, and I want to know the pressure of the dry gas. So basically I have two gases here, okay? I have the dry gas and I have the water. The dry gas is the oxygen. So the pressure of the oxygen plus the pressure of the water is going to equal the total pressure. So here's my total pressure, 760 torr. I am looking for the pressure of the dry gas, which is the oxygen. And I have been told that at 25 degrees Celsius, the pressure of water is 23.8 torr. So when I plug that in, we get 736 torr is the pressure of the oxygen. So number 2, a 32 ml sample of hydrogen is collected over water at 20 degrees Celsius and 750 torrs of pressure. What is the volume of the dry gas at STP? Okay, so we want to know the volume of gas. So first I have to find the pressure of just the hydrogen. All right, in order to find the volume, I need to know its pressure, and then we can set it up into a PVTN chart. So my total pressure is 750 torr. And that is going to equal the pressure of the hydrogen plus the pressure of the water, which is 17.5 torr. So the pressure of the hydrogen is 732.5 torr. All right, we're not rounding yet. We're going to round at the end. So now I can set up my PVTN chart where I have my initial, my final, and my effect. Okay, my IFE chart. Moles is not involved here. All right, my pressure of hydrogen is 732.5. My volume is 32 mils. And I didn't really leave myself enough space here, did I? My temperature is 20 degrees Celsius, which is 293 Kelvin. All right, and we're not using N. Okay. My volume is going to go to STP, standard temperature and pressure. So my standard pressure in torr is 760. My standard temperature is 273. So my pressure goes up, which is going to cause my volume to go down. So I'm going to set up my ratio, 32 mils. And if I want to get this number to go down, I have to put 732.5 on top and 760 on bottom. Now let's look at my temperature. My temperature goes down. So a decrease in temperature is going to cause a decrease in volume. So in order to get this 32, remember it is a separate part. So to get 32 to go down like I want it to, I have to put 273 on top. And when I plug that baby into my calculator and I use my rule of 3, I get 28.7 milliliters. All right, number 4 or number 3, go ahead, pause this video, try number 3, and then come back and check your work. All right, so in number 3, we see our total pressure is 770 torr. The pressure of oxygen is what we need to find in order to find the volume of oxygen. The pressure of water is 21.1 torr. So my pressure of oxygen is going to be 748.9 torr. And now I can set up my chart, my IFE chart, where my initial pressure is 748.9 torr. My final pressure at STP, my final pressure in torr is 760. My initial volume is 54 mils. My initial temperature is 23 degrees Celsius, which is 296 Kelvin. And I'm going to STP, so my standard temperature is 273. Moles is not part of it. All right, so my pressure here increases. So an increase in pressure causes a decrease in volume. So how am I going to get 54 milliliters to go down? I'm going to put the 748 on top and the 760 on bottom. Now my temperature goes down. So a decrease in temperature is a decrease in volume. So how am I going to get 54 to go down here? I'm going to have to put the 273 on top. All right, and when we plug this baby into our calculator, we get a final answer of 49.1 mils, again, following that rule of 3. All right, number 4. A mixture of 2 moles of hydrogen, 3 moles of ammonia, 4 moles of carbon dioxide, and 5 moles of nitrogen gas exert a total pressure of 800 torr. What is the partial pressure for each gas? So here we're looking at the relationship between pressure and the number of moles. So we're going to do a mole fraction. So what we have to first do is figure out the total number of moles within the gaseous system. So I have 2 moles of hydrogen, 3 moles of ammonia, 4 moles of carbon dioxide, and 5 moles of nitrogen. So I have a total of 14 moles of gas within the system. Now these 14 moles cause 800 torr of pressure. So let's look at hydrogen. And how are we going to find the partial pressure of hydrogen? I can look at the fraction of moles of hydrogen. So 2 divided by the total times 800 torr. And that gives me 114 torr. So hydrogen is exerting out of this 800 total 114 torr of pressure. So ammonia is exerting 4 moles out of the 14 moles times the 800 total, which is 171 torr. I have 4 moles of carbon dioxide. There are 14 total moles. 800 torr. So when I plug that in, I get 229 torr. And finally, I have 5 moles of nitrogen out of the 14 moles times the 800 torr. So nitrogen is exerting 286 torr. Now, because of rounding, you may not add up to exactly 800, but you're going to be so darn close that it is 800. Take this, plug this into your calculator, and when you plug all 4 of those values in, do you get 800? And when I plug it in, don't worry about that top one. I messed up. I get exactly 800. So this is a way to check your work. All right. Do your partial pressures actually add up to what they should? Okay. All right. Let's do one more. All right. And let's look at our percentage. Now, in this particular problem, we have the partial pressure of fluorine gas in a mixture of gases. The total pressure is 1 atmosphere, and we have 300 torr. Okay, so what this is saying here is it says the total pressure. So 1 is the total pressure, and this 300 torr is the partial pressure. So it doesn't read clearly, but this 300 torr is the partial pressure. All right, so I need to either convert atmosphere into torr or torr into atmosphere. All right, so I'm going to choose to convert torr into atmosphere, where 1 atmosphere equals 760 torr, so 0.395 atmospheres. All right. If you had taken this atmospheres and put it in torr, you would get the exact same answer, final answer. Okay. So what we're going to do to find the percentage of fluorine, we are going to take the pressure that fluorine is exerting and divide it by the total pressure. Let's multiply it by 100 to give us a percentage. All right, and that is going to give us 39.5% fluorine. I might suggest you try this the same way, leaving torr and converting atmosphere into torr. You should still get 39.5%.